My name is Jeff Broom, and I'd like to introduce StrataCode. I've been fortunate in my career that I've helped architect 3 successful software platforms, and I've taken just the patterns that I've seen that work really well and put them into StrataCode. I'm happy to report that it's usable today, and we're seeking alpha testers and more partners and hope to open source release everything soon. The mission for StrataCode is to improve software efficiency. And one of the key ways it does that is by using layers as a new paradigm for organizing code, data, and files. And I've had experience with this pattern before and seen how well it works, and I know it will work even better at the language level. But StrataCode is way more than just layers. It also includes key improvements for how business and engineering work well together. And one of the key ways it does that is to put more people in control over features using faster and easier customizations. And because of the technology it's built on, synchronization, filtering, workflow, it will have higher fidelity integrations that are more under your control. And it gives you a fundamentally new way of packaging features in your software products to merchandise software better. And we put businesses more in control by giving them customized management UIs, so the right form is in front of the right person. And just like Excel, you have live editing of business rules. You can change them and see how they affect the application on the fly. But even though this pattern is at runtime, they're still deployable as compiled code at scale. And StrataCode's layers support great workflow that manages dependencies between code, data, and files. And StrataCode's more efficient for engineering. Layers let you do less code copying, and the structure of the frameworks separate the application code from the framework code. So the application code's more readable and reusable. And it uses the reactive declarative code model, where less does more. And StrataCode's included just the right patterns for readable, reliable, fast code. So your code does what you think it does, and you always know what it's going to do. And the patterns and frameworks are low latency, and real-time is a feature you can just turn on. And the design of StrataCode will ensure it's scalable for large volumes of code, large numbers of users, and big data sets. One of the key engineering benefits is to use one language for client and server. And StrataCode does this by taking Java and compiling it to very efficient, readable JavaScript that matches the Java almost one-to-one. And framework developers have more control over the skeleton features, the code skeleton, which is how they manage objects instances, their life cycles. Are they request, per window, per session, global, or maybe per tenant in a multi-tenant situation? That's all done at the framework level and then turned on and off either with defaults or through annotations. And framework developers can customize how you get and set properties and manage references even when they get complex, so they're recursive and point back to the referencing component. And StrataCode synchronization gives you robust, stateful client-server applications. And so even if the server fails, the client, even though it's stateful, still can fail over. And all of these features work in a live programming environment with a statically typed language based on it's an extension of Java. So StrataCode at its core is just a Java code preprocessor. So if you put a bunch of Java code in, it compiles it and runs it. But it also includes extensions to Java in the StrataCode language and frameworks and integrations. Some notable ones are the Java to JavaScript conversion and multiple inheritance. The others we've talked about. Layers are really more flexible objects. They're just an organizational extension to Java, like Delta-oriented programming. And each layer is just a directory of source files where if a file has the modify operator, it merged into the previous layer with the same name, with a file with the same name, producing a Java class, at least in the compiled layer's case. And the modify operation looks just like plain old inheritance. You have one syntax to do the same thing. So for uses for layers, when you copy code between layers, you can do it in a compatible way. You can create new layers and move code around without affecting downstream layers. And of course, layers support the simple pattern that's used commonly today to patch one or more files in some code you're using. That's just putting a couple of files in a layer. But if you're designing with layers up front, you might organize that code by dependency to reuse it in the best way possible. So the code that depends on the browser is in one set of layers, the mobile in another, etc. And you can organize it by function, so different people are working on different sets of files. That often amounts to the same thing. And with StrataCode's client-server synchronization, you can have shared layers that run on both the client and the server that run in an isomorphic way. So the HTML is rendered on the server the first time you load the page, and then the client can incrementally update it. And then you can have layers that run only on the server, only on the client. Layers also give you incremental universal customization, so you can modify any property, override any method, as long as the developer allows that in the protection scheme. And one of the key syntactical extensions that StrataCode provides is data binding. And this is really the only thing that affects how code is readable. So I'm going to go into this in a little detail so you can read StrataCode files. A:=B is a forward binding, where B is any Java expression and A is some property on an object. And it says that when the expression changes, so anything that could affect the expression, StrataCode will listen for events on those properties and update B, even if there's a method call or expression in the way. And A=:B is a reverse binding. So in this case, when the property A changes, the expression B is updated if it's a simple property, or if it's a method call, it'll just evaluate that expression. And A::B supports bidirectional binding in the case where B is an invertible expression. So there's an inverse expression we can compute. And if you have a method call in there, you can specify an inverse method with an annotation, so it can make even complex formula be invertible when methods are involved. StrataCode is based on an innovative code processing framework that has a traditional grammar that has additional annotations to generate a model. But then when you listen on the changes on that model, the code gets incrementally updated. So if I change an expression or an identifier, only the relevant parts of the file change. And this lets you read, modify, and write code from frameworks or tools, and just makes it easier to process code. So for example, translating between Java and JavaScript was implemented by one person in 2 months and just a few thousand lines of code, to the point where it could translate lots of Java utilities directly from the Apache Java distribution. And within the year that it's been developed, it's now very robust from the debugging and use we've had on it. And when you have better frameworks and integrations and better code processing, it means everything upstream will benefit by doing things in a faster, more robust way, because you can interpret formats as they change and do synchronized and read, modify, write operations across the board. And that's why I hope you'd like to learn more about StrataCode, and go to stratacode.com for more, and there's a web demo on YouTube. And certainly email me with any feedback or questions, and thanks for watching.